Welcome back to All This Math. This is Professor Parker, and today I got my FAMU. I got some FAMU swag on. FAMU, Florida A&M University. My son, this is one of the schools he's applying to. I don't know if he's going to end up down there in Tallahassee, Florida, but he might. Who knows? But at any rate, shout out to FAMU and the Rattlers down there. As I said, Tallahassee, Florida. Rest in peace to the ancestor, Dr. Kobe Cambone. A great African-centered psychologist and psychiatrist or psychologist who actually taught at Florida A&M University. Shout out to him. Rest in peace. So, what are we going to get into for this lesson? We're going to do some work with negative exponents. Negative exponents. Now, the negative exponent rule is one of several rules that you need to learn if we want to simplify expressions or solve problems that involve exponents in them. All right, you got the multiplication rule for exponents. You got the division rule for exponents. Some textbooks call them properties instead of rules, but we can use the word property and rule interchangeably. So again, multiplication rule, division rule. There's the power rule, right? There's the power rule. There is the zero exponent rule. So that's 4, zero exponent rule. And we got the negative exponent rule. So that's 5. All right. Now some textbooks make a distinction when you have a fraction inside of a set of parentheses, when you have a fraction raised to a power, and they'll use that, they'll kind of extrapolate from what we call the power rule and identify that as a separate rule. I typically don't, because what happens is with the power rule, what you do is you take the exponent that's inside the parentheses and multiply it by the exponent that's outside the parentheses. That's pretty much what you do. And these exponent rules are important because when you're dealing with algebra, you need to know the exponent rules so you can simplify expressions. You need to know the exponent rules later so you can solve logarithmic equations. All right? And even when you get to calculus, you need to understand the exponent rules because a lot of the exponent rules are directly related to a lot of the rules that you use to derive functions or to find the derivatives of functions, like the power rule in calculus, right? So, all right, so now, but the negative exponent rule is like this. What you do, and we got 4 examples up here. 4 to the negative 2 power, 5 to the negative 3 power, 2 to the negative 4 power, 3 to the negative 1 power. And I want you to learn these rules because a lot of students, and I've encountered this throughout my career, right? I've been teaching for almost 20 years, right? A lot of students, if they don't know the rule, they take an educated guess. They say, all right, well, I know that 4 to the second power is 16, right? So if it's a negative 2, instead of it being a positive 2, the answer should probably be negative 16. Why not? That makes sense, don't it? That's wrong, right? First off, if you have a positive 4 and you are applying an exponent to it, you can't end up with a negative, right? You won't end up with a negative because when you square something, you're multiplying something by itself, all right? You're multiplying something by itself. And when you're multiplying a positive times a positive, you end up with a positive. When you multiply a negative times a negative, you end up with a positive, all right? But this is just an issue of not knowing rules, and we got to learn rules. That's one of the things with math. Math has a lot of rules. You just got to learn the rules. I mean, it's just like with sports. Football got a lot of rules, but we learn them. Basketball got a lot of rules, but we learn them. If you play baseball, baseball got a lot of rules, but you learn them. Every sport got a lot of rules, but you learn the rules because you want to win. Same thing with math. If you want to win in math, you got to learn the rules. Straight like that. Yeah, you no way around it. And what you'll find is that through practice and doing a lot of problems, you'll reinforce what the rules are, and then you'll just naturally know them, and the rules will become part of your own muscle memory, and it'll be cool. All right, so check this out. 4 to the negative 2. This is what you do whenever you see a negative exponent. What the negative exponent is telling you to do is take the base. Now, what's the base? The base is the number or the term that carries the exponent. This is the exponent, negative 2. This is the base, 4. This is the exponent, negative 3. This is the base, 5. This is the exponent, negative 4. This is the base, 2. This is the exponent, negative 1. This is the base, 3. Right? The negative exponent is telling you to take the reciprocal of the base. That's what the negative exponent is telling you to do. Take the reciprocal of the base. Take the reciprocal of the base. take the reciprocal of the base. Now, what's a reciprocal? All right, that's another math term. A reciprocal is a term that is what we call like let me give you a more complicated term, right? The multiplicative inverse, right? Basically, all that means is you take the numerator, if the number was written as a fraction, right? If the number was written as a fraction, you take the numerator, move it to the bottom, make it the denominator. You take the denominator, move it to the top, make it a numerator. That's it. That's all a reciprocal is. It ain't that deep. That's all it is. So for example, notice I said if it was written as a fraction. 4 is not a fraction, right? But we also got to know, how do I make any whole number, because 4 is a whole number, or integer, because 4 is an integer also, how do I make that look like a fraction? I do this. I do 4 over 1, and I'm going to put it in parentheses, right? Because now I got a fraction. Now that 4 looks like a fraction now, right? So what the negative exponent tells me to do is, and it's a few ways I can actually simplify this based on how it's written now, but what the negative exponent tells me to do is take the base and take the reciprocal, or flip it. So this is going to become 1 over 4. Now, check this out. What happens to the exponent once I do that? This is what the negative exponent rule says. It indicates once you flip the base, now the exponent becomes positive. And why is that important? Because we can't use exponents if they're negative. We can only use positive exponents. So we got to do something in order to make that exponent become positive. So now we got 1/4 to the positive 2 power. So now we can actually use that exponent. We can't use -2 as an exponent. We can't use -3. We can't use -4. We can't use -1. But once we convert the base, then we can use the exponent, because now after we convert the base, then the exponent gonna be positive anyway, and it's cool. Then we can work with that. So now we use something called the power rule. So we got 1 to the second power and 4 to the second power, because everything inside the parentheses gets hit with this 2 exponent. So 1 to the second power is not 2, right? We're not just multiplying this base times the exponent. We ain't doing that. If anything, we're multiplying the exponents inside by the exponent outside. This 1 has an invisible 1 exponent. 1 times 2 is 2. So that's really, let me show you all the steps. 1 to the second power. This 4 has an invisible 1 exponent. So that's 4 to the first power. So that's 1 times 2. So we got 4 to the second power. So we got 1 to the second power on top. We got 4 to the second power down the bottom. So 1 to the second power is 1. And 4 to the second power is not 8. I know that's a very common mistake. 4 to the second power is not 8. 4 to the second power is 16. So we got 1/16. 4 to the -2 is equal to 1/16. So basically what you do is take the reciprocal of 4, you get 1/4. Now the exponent is a positive 2. You do 1 squared and 4 squared, 1 squared and 4 squared, 1 squared and 4 squared, giving you 1/16. All right, so you got 1/16. So now we got 5 to the -3 power. All right, 5 to the -3 power. So since we have 5 to the -3 power, now what happens is we're gonna do the same thing. I can't use a negative exponent. I can use a positive exponent, but I can't use a negative exponent. So the question is, okay, well, how do I change that exponent to a positive? Because I'm trying to use it, so I can simplify the expression. I got to take the reciprocal of the base. What's my base? My base is 5. What's the reciprocal of 5? The reciprocal of 5 is 1 over 5, or 1/5. So this is going to become 1/5 to the third power. 1/5 to the third power. So now I got 1 to the third power, which is 1. And I got 5 to the third power, which is 5 times 5 is 25. And then 25 times 5 is 125, right? 5 nickels 5 times is 25 cents. Then 25 cents 5 times is $1.25, or 125. So that's 5 to the -3 power. All right. Then we got 2 to the -4. Again, I can't use a negative exponent. I can use a positive exponent, but I can't use a negative exponent. I want the exponent to become positive. But I can't just willy-nilly again, change it to a +4. I can't do that. We got to follow the rules. So in order to change this -4 to a +4, the base has to become its reciprocal. So what's the reciprocal of 2? 1/2. 1/2. So you got 1/2 to the 4th. So 1/2 to the 4th, then you got 1 to the 4th, that's 1. And 2 to the 4th is, again, not 8. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. That's 4 2s. So that's 1/16. 1/16. That's 2 to the negative 4 power. Then we got 3 to the negative 1. Again, I need a positive exponent. So this negative 1 needs to turn to a positive 1. So I got 1/3 to the first power. Reciprocal of 3 is 1/3. Reciprocal of 2 is 1/2. Reciprocal of 5 is 1/5. Reciprocal of 4 is 4/1. Oh, no. I mean, okay, I had it right here. I did it the long way. Reciprocal of 4 is not 4/1. It's 1/4. Remember that. So now use the power rule. 1 to the first power is 1. 3 to the first power is 3. 1/3. All right. But look at these answers, though. Look at these answers. 1/16, 1/125, 1/16 again, 1/3. Check this out. What's 4 to the positive 2 power? 16. What's 5 to the third power? 125. What's 2 to the fourth power? 16. What's 3 to the first power? 3. Notice how, if these exponents had been positive with the same bases, we'd have had the reciprocals of the answers that we got. 16 versus 1/16. 125 versus 1/125. 16 versus 1/16. 3 versus 1/3. So keep that in mind. Keep that in mind. So when you see expressions, right, that you have to simplify, and you see negative exponents, just know that you have to take the reciprocal of the base. Now, before I end this video, let me point something out that causes a lot of problems for students. These were very basic and introductory and straightforward examples, including the negative exponent rule. They're not all going to look like that. Let me just forewarn you. Sometimes you might see an example like this. You might see like something with a variable in it. You might see 4x to the negative 2 power, right? And you might think, oh, I see a negative exponent in that expression, right? And I know that, when Professor Parker was talking on the video, he kept talking about, well, we got to take the reciprocal of the base so that we can make the exponent into a positive. That's true. But where a lot of students go wrong is here. They don't correctly identify what the base is. In this expression, negative 2 has a base of x, not a 4. This 4 don't got nothing to do with this negative 2 right here. This 4 is minding its business. It's part of this term, but it don't got nothing to do with this negative 2. So if you take the reciprocal, you should only take the reciprocal of x. Now, what does that look like? That looks like this 4 still being there, right? But then you have 1/x to the second power. 1/x to the second power. That 4, you do not take the reciprocal of 4. You should not write 1/4x. And I'll tell you, this happens so often. Like a student will think, oh, well, I see an exponent, negative 2, and I see a 4 and an x, so let me just flip everything. You can't flip everything. You only flip what actually has that exponent, or what carries that exponent. The 4 is not carrying this negative 2. Now, check this out, though. If you saw this, 4x in parentheses with a negative 2, these parentheses mean that this negative 2 do got something to do with this 4. This negative 2 got something to do with everything inside the parentheses. That's what happens when you got an exponent outside the parentheses. It means that the exponent's got something to do with everything inside the parentheses. In this case, there's no parentheses. There's none. So this negative 2 is only affiliated with this x. Even though the 4 is affiliated with the x because it's the coefficient, but according to the negative exponent rule, this negative 2 don't got nothing to do with that 4. And you're going to see examples like that. So I just want to forewarn you. I just want to put that out there. Excuse me. Yeah, I just want to put that out there. And I think I have some other videos on the channel already under my exponents playlist that get into examples like this, where I drill in on this, because this is again, in my long teaching career of almost 20 years, I've seen this a lot, where they'll flip the 4 also. They'll flip everything. Students will just flip everything. But what you got to do is you got to be detail oriented. Look at the expression and say, okay, I see a negative exponent. Cool. I need a positive exponent. Okay. I got to take the reciprocal of the base of that negative exponent in order to make it into a positive exponent. But I got to be very careful in terms of identifying what is the base of that negative exponent. What is the base of that negative exponent? Got to be very careful, right? You got to be very detail oriented with math. And that's what one of the things I like about math. It teaches young people, it teaches people in general to learn to be detail oriented and to cross your T's and dot your I's so your answers come out correctly, right? And that's a transferable skill. So you can do that in math class. You can do that in other areas of your life too. You know what I mean? So, all right. So, yeah, so this was just a little bit of introduction to the negative exponent rule. So what you need to do is ask your teacher, ask your professor, ask whoever, or go online and get some practice problems that look similar to these and just practice using the negative exponent rule, simplifying expressions that have negative exponents. All right, remember, you can't use an exponent if it's negative, so you got to convert the exponent to a positive exponent, but then you got to take the reciprocal of the base, but you have to correctly identify what the base is. All right, so go get you some practice. I'll catch up with you in the next video. Again, shout out to FAMU. Peace.